In the last video or so, we introduced the idea that WASM can run in your browser as a stack-based virtual machine, but that it cannot interact with the outside world without some help. We introduced that in a browser, this would typically be via JavaScript. And you might be wondering, so what? Why should I care? I think technology is changing and WASM is going to become more and more of a thing. Let's say that you are curious, but still don't understand why do WASM in a browser? Why not just use JavaScript or any of its derivatives? We do want to answer that question, but first we need to actually know how to combine JavaScript and WASM in the browser, something beyond just the demos you've seen on this channel. If you've been following along, you've seen these videos do simple little programs, right? We've printed to the screen, hello, hello world. We've done if, then, else. We've done loops, like for loops, while loops. We did some of these in high-level languages, and we did some in assembly. What we're going to do now is combine JavaScript with WASM, or WASM. All the steps are going to be in a file, and I'll provide a link to that file in the comments. So step number one is ask Gemini for a simple loop program that will run in the WASM runtime machine. We are going to turn this into WASM bytecode, okay? To do that, we're going to use something called AssemblyScript. AssemblyScript is a TypeScript-based programming language optimized and statically compiled to WebAssembly, WASM. Designed by the AssemblyScript project, it allows developers familiar with JavaScript and TypeScript to write high-level, strictly typed code that compiles into lean, efficient WebAssembly modules using binary and compiler toolchain. Now, later on, we'll be talking about other higher-level languages to compile to WebAssembly. Step number two is to set up your environment to compile the above into WebAssembly. Now, this is pretty much going to be the same whether you're on Linux, Mac, OS, or Windows, and it's mostly going to be terminal-based steps. And I'm sorry about that. I've tried to stay away from that for all these series, but here we are. You need to have installed the Node Package Manager, NPM. This is not meant to be a video on installing npm or Node, so I would suggest go to your browser and look up install npm via nvm. We need the npm installer in order to install AssemblyScript in order to compile our loop code into WebAssembly. Now, once you've installed npm, we use it. I prefer to do local installs instead of global, especially when I'm just playing around or learning. In order to install locally, run this first. So you got to run it in the same directory where your counter.ts file is, by the way. So this code here that's going to turn into WebAssembly, put it in a file called counter.ts. In that same directory, run this npm init-y. You'll then see a new file called package.json. Now we're ready to install AssemblyScript. And so in the same directory, run this npm install AssemblyScript, all lowercase, -- save -dev. Okay, we're ready for step three. We're going to compile that counter loop code, which is in counter.ts file, right? We're going to compile it into WebAssembly in that same directory. N, Nancy, Paul, Xavier, ASC, that's the AssemblyScript compiler. And the input is counter.ts, -o means output. You want it to output to counter.wasm, and you want it to optimize the code. So by now, you have at least these three files in that directory: your original loop code written in AssemblyScript, the package.json that was required so that we could do things locally, and there is your actual WebAssembly file. We're going to take a look at that. Okay, so step four, we are now ready to take a look at our new WebAssembly file. Now, we can't read bytecode directly, just like we wouldn't be able to read machine code for real processors, but we can disassemble it. We can get a text-based version of it, which is essentially WebAssembly text format. So to do that, in the same directory, run mpx wasm to wat counter.wasm. That's our WebAssembly file, and you want it to output to counter.wat. So that's another fourth file that you should be added to this list. And then let's take a look at that file. And there it is. Now, a lot of it, we obviously didn't cover in any of our demos, but some of it you should, like for example, we've seen this, right? With a little demo I did with the browser, little animated demo. We saw the ad. The rest of it is different because we were using, in our example, here's one right here. We use this one. That's a literal one, value of one. So anyway, that is the text version of WebAssembly. All right, step 5, ask Gemini for a complete HTML plus JavaScript file. I spelled that wrong. That will load our new counter.wasm file and also run it. It'll be our HTML plus JavaScript file will be the outside world as far as the WASM loop code is concerned, so that we can actually see some results. And I saved that file separately. I'm not going to add it here, but here is the file. I can show you the code. We can look at it in detail some other time. I don't want to go over it right now, but we're just going to run that. So that will be step 6. However, to run it, all right, step 6, run your new HTML file to see things in action. And I'm sorry, the entire channel, I have tried to stay away from the terminal and the command line and all that for everybody, but here we are. So I would search for install Python on Windows. Why? Because this will allow you a way to run a tiny web server. In all the previous videos we've done, we've run the files as like this on the URL bar of the browser. That's not going to work because of browser security when trying to load a WASM file. Okay, so I have Python installed, and this is what you would run, that little mini HTTP server or web server. And then what we do is we pull up a browser, we'll bring it over here, and we go local host 8000, right? Because that's the port that's right here, 8000, yes. 8000. And then I got to go look. Oh, there it is right there. Where it goes, because I'm running in the same directory. Yes, of course it is. Okay, so let's make this big. I don't want to get this video any longer, so I won't delve into the details of any of this right now. We're just going to run it, okay? So run WASM loop result 45, whatever that means. Now, let me show you something before we stop this video. Inspect. And let's go to debugger, which shows you the files. There they are. Let's make that bigger. Okay, so this is our main HTML file, and it has JavaScript down here, which, by the way, let's see if I can show you. Look, where is it? Where is it? Right here. It is trying to fetch or load our new WASM file. That's how it loads it into the JavaScript environment. Here is our file. Now it says, please refresh to debug this module. So, okay, we'll do that. Oh, look, where did we see this before? When we did the WASM to what? There it is. It has disassembled the WASM code for us. I don't think we can can we hit break? Let's try it. Oh, that would be cool. Will it actually break? Let's run it. It does break. Your browser allows you to step through. Yeah, we can step through. Yeah, we can. Okay. Okay, but now, anyway, I don't want to go any further right now. We'll investigate this later on, but eventually it gets out of the WASM code. Oh boy, wait a minute though. The problem is that we're doing a loop. I better get out of here. Let's just continue. And then we're back. I guess if I had done a loop of 1, let's do that again. Let's do it at the top here. We can break wherever there's a dark text. Okay, run the loop. Okay, we'll step through it real quick. Da 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 da. Okay, it's at the end. I don't think it's going to keep going. Yep. And now we're back to. That's it. That's the end of it.